Well, hello everyone. We are back here to the final review for chapters 10 and 11. This is every single problem on the test. I can guarantee you with 100% certainty that if you watch this video today and you know how to do everything on here, you will do fine on that test because every single type problem I'm going to show you. So here we go, heating curves. Here's what a heating curve will look like. You've got this area here, which is what? Solid. And then this area here, melting. This area here, liquid. Here, vaporization, boiling. And here, gas. The things to notice, these flat lines, those are the points. Melting point, freezing point, condensation. A, C, E, that's the heating. Heating of the solid, heating of the liquid, and heating of the vapor. So what type of questions might you get? Well, which letter on this graph represents the melting of the solid? Which letter represents boiling of the substance? What about heating of the gas? Remember, we just talked about that. What about freezing of the liquid? What about the melting point? Notice I might try to trick you a little bit here. Melting of the solid and melting point. What's the key word? Melting. And heating of the liquid. So as you can see, here are the answers, but take a look. This is B, 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 freezing of the liquid, melting point, melting of the solid. Those three are the same right here. The heating of the gas, that's up here, that's the E. Heating of the liquid, that's right here. So make sure that when it's a heating, you know that it's one of these. And when it's melting or freezing, it's here. And when you've got this here, you've got the boiling or the vaporization. Now the next diagram you're going to get is a phase change graph. It's probably going to look something like this. Possible questions that you might have. Well, what's stayed at a certain pressure and temperature? So I'm going to give you a pressure, let's say 70, and temperature of 500. So, what is it? That's right, that's a liquid. Or I might say it's at 30 and 400. Well, that's right there. Well, what if I said that I went from my 7,500 down to 30,400? What's the phase change? Not that it went from a liquid to a gas, but what's that change called? A liquid to a gas is vaporization, sometimes known as boiling as well. But that's the change. Okay? The other thing you might have is you're going to have a graph like this where these are going to be blank. You're not going to have that word or that word or that word or that word or this down here. So I need to know that this is melting and this is freezing. I need to know that this is vaporization or boiling and that this is condensation. And then I need to remember that if I go from a solid all the way to this gas, sublimation, exactly. So these are the three type diagrams that I'm going to have on that test tomorrow. So I know how to do all these diagrams. I know I'm going to do pretty well on this part. Then I have a section on exothermic or endothermic. Remember that exothermic is the releasing of the energy. That means the delta H is going to be negative because it's on the right-hand side of the arrow, meaning after things happen, energy was released. That's why it's on the right side. Endothermic is absorbing, meaning I need energy until my bonds break apart. That's delta H is positive, or energy is on the left side of the equation. So let's take a look at some examples. So right here, I have a lot of stuff going on. But I look down here, this is what I'm looking at right here. I actually don't care about any of this right here. I just need this. Delta H is negative, so I know what to do. Here, again, I don't see a delta H, so I need to look in the equation. There's the arrow. I look, I see nothing over here when it comes to heat. Oh, there it is. So arrow, heat is on the right side of the arrow. Notice the difference. Here, yes, it's on the right side, but it's a delta H. That overrides everything. I look for the delta H first. I don't see delta H, I then go to the equation. Here, arrow, nothing. Oh, here it is. Heat is on the left of the arrow. And my last problem again, heat. Oh, there it is, left of the arrow. So let's see how you did. So the first two are both exothermic, and the last two are endothermic. Again, exothermic because delta H is negative. Exothermic because it's on the right side of the arrow. Right here, it's on the left side of the arrow, and it's on the left side, which is why the last two are endo. So now we've gone through the phase diagrams, we've gone through the heating curves, we've gone through exo and endothermic. The only thing left are the Q equals MC delta T problems. So Q is equal to MC delta T. Q is our joules, M is our mass, 4.18 joules per grams degrees Celsius is our specific heat. Notice, it says for water, and delta T is the change in temperature. I don't use both numbers and multiply them together. I subtract them. I figure out the change. So if I'm looking for Q, I take the three things, multiply it together, remembering that C is my constant. If I want M, it's Q over the other two. Remember we said, if given Q, it's Q over the other two. Again, Q over the other two, Q over the other two. So let's take a quick practice problem here. So when 48.5 grams of KOH, oh man, I don't know the C for that, is dissolved in 15.8 grams. Oh, great. Water, good. I'm always looking for that water. The temperature decreases from 23 to negative 10. So I go down to 0 and then 10, so that's 33 degrees. Notice that negative is really going to cause some problems. So what are you looking for? Well, you're looking for heat because I don't know Q. I have grams, that's a mass. I have change in temperature, so I have that. I know a constant. Q is the only thing left. So, what are you given? Well, you're given the mass, 15.8. Remember, we only use mass for water. Change in temperature, 23 to negative 10. Well, that's going to be 33 like we said. Again, not 10 minus 23. It's 23 minus a minus 10, which is 33 degrees. So if I fill it all in, again, mass of water only, my constant, which is 4.18 joules per grams degrees Celsius, and 33 degrees Celsius. So if I plug that in here, I'm going to multiply all those three things together. And when I do that, you get 2,179 joules. I easily could say 2180 because that's what the significant digits are. But I just left it as the whole number so you could see all the steps that I'm doing here. Well, now, that's great, but a lot of you are going to say, well, what about these joules per mole things? Well, that's where this 48.45 comes in. First thing, do it right away, find the moles of KOH. In order to do that, I need to look on the periodic table for what K, O, and H are. So I know that I had this many joules, but I want joules per mole. So this is where I needed to use the KOH. K was 39.10, O is 16, H 1.01. I got that from the periodic table. I found the K, I found the O, I found the H. I add them all up and I get 56.11. So how do I do this? Well, I take my molar mass here, my grams will cancel, and I am left with 0.863 moles of KCl. I then take that previous answer that we talked about, and I divide it by this new answer, and I'm going to get 2,530 joules per mole. That's it. You don't need to add more stuff. You don't need to stop. That's it right there. So we've gone through every type problem that you're going to have. I guarantee you're going to have to solve for C on probably 2 or 3 problems. You're probably going to have a couple that you have to solve for Q, and there's going to be 2 just like this with different numbers. Maybe even one that looks exactly like this. You never know. But the work is what's important. Again, if you have any questions, email me, mcmannr@royaloakschools.org. Come in tomorrow morning around 7:30 after the student council meeting, and I will be happy to answer anything for you. Have a great evening studying. I look forward to all A's on the test tomorrow.